Let's go through some debugging examples. First, we want to start out with echoing. There's some Python code here. I'm hiding some elements of the code for simplicity so we can more easily go over this. Initially, we're defining a function that has the name sum of elements. It gets an input array, and it defines an internal variable. It loops over the input array, pulling each value in the array into the variable x. And then it adds to s the value of x. So in the first iteration, this would be 0 plus x, goes into s, etc. Outside of this function, in the main body of the code, there's another variable that's called x, could be a better name than that. And that gets assigned the return value of the function sum of elements that is given this list of 3 values. Now we're printing the result. Okay, so we could run that, and all we'd know at the end is that there's a result that is being printed. Now, if we want intermediate results, we could, for instance, add a few functions here. We could say print, we are in sum of elements now, so not in the main code. And then we are in the for loop. We are trying to calculate s plus x. So this is this integer plus this integer here, which should equal s plus x. So then we're doing this operation, and then we can compare that s actually has the new value, and we can compare whether those values are the same. At the end, there's an end sum of elements, and then we're executing. This code is not going to work. It's doing its job, but down here, when we print x, we will get none. And I'll walk you through that in the live example a little bit later. But this is how we could insert print statements. I will say that for large arrays, whatever's happening in here is going to overwhelm you. So you probably want a smarter strategy than printing intermediate results multiple times for each iteration. But for this small example here, this is going to be good enough. So here we have almost the exact same code as we just looked at. There's a critical change. The print function now is called print underscore debug. And I have replaced that here, here, and here, and here. So wherever we want output only when we're actually looking for errors, I've used this new function. The print functions down here are still the same. Now what I can do is I can add the print debug function, which simply takes a string that's to be printed, and if a global debug flag is set to true, and I set that outside here for simplicity to true, then we're printing what we're given. Again, I'll be showing in the live example how we can turn debug off and on with this little function. The key thing is that these print statements can maintain with the code. You just have to turn off the global flag, and all this work that you put in and trying to figure out where good debug output could be placed can stay there, and your code will run without always producing this output, because it will only be generated when you set your global flag to true. An example for unit testing that I grabbed off of the Python documentation could look something like that. We're importing the module unit test, and we're defining a class test string methods that becomes, through the syntax, part of unit testing. We have not talked about classes or object orientation. We will go into that in later courses. For now, just think that test string methods is going to be executed anytime we are we're executing our main function in unit tests. Okay, this is a way how we can tell the module unit test there's something that needs to be tested. Okay, and in the class, we're defining different functions that all should be tested. So here in the first function, we say test upper. We assert that foo.upper, so converting the string foo to uppercase letters, is equal to foo in all capital letters. We can also test a function that strings provide that is called isUpper. So here we define a string foo. We ask whether or not this is all capital letters, isUpper, and that should be true. And foo with just one capital letter, if we ask the question isUpper, that should be false. So we are testing two cases in this one function, whether or not these string functions are working. The last test that is implemented here is test split. So we simply give ourselves a string. The split function has the task to divide a string that has white spaces, like here, the space between hello and world, into a list that contains the elements. So we can test here that s split, so hello world split, should be the same as hello world, right? We know what the output should be. We are testing the function that we want to test here. Those two should be equal. That's what assert equal provides, that comes with the unit test case class. We also want to make sure that, the separator, if that is not a string, so here split, the function takes separators. It could be any kind of string. It could be world, or it could be WO, it could just be O. But if we're giving it something else, like here, the number 2, then that should raise an error. The function test split is going to succeed if that actually does raise the error here. And then we just run the test. So you can see that is a little bit more involved for ensuring that the code is working fine. You probably will not use that for small lab size examples, but as you start writing larger software packages, this is going to be very important to ensure the consistency of your code, that it maintains its functionality. And obviously all of these functions here would be your own and not the functions for the standard string package. The last technique that we can talk about here briefly is exception handling. The motto is that we want to keep the program running, even in cases where things go wrong. So we want to keep the program running in recoverable ways. So again, this comes from the Python documentation. There's a function defined that is called this fails. There isn't anything else happening other than dividing 1 by 0. Division by 0 is not defined. So if we call this function at any point, the program is going to stop, unless we embed this in try except brackets. So if we call the function this fails in a try block, and then we catch the error that is defined within Python as 0 division error, as some error, we can print handling a runtime error, division by 0. But the code is going to keep running. We'll see that too in a live example.